Imagine a bank with no restricted areas, where any customer walking through the lobby can walk straight past the tellers and directly into the main vault. In the digital world, that architecture is known as a flat network. It is a design where every device, from a student's phone to a school's central database, shares the exact same digital space without any internal barriers. Adversaries favor these environments. Once they bypass the initial perimeter defense, they have a clear, unobstructed path to every other system on the network. Relying on a single outer wall to protect an organization creates a massive point of failure. Modern security requires internal boundaries to stop a breach from spreading. Look at the network at Oak Ridge High. You have student devices on the Wi-Fi, teacher laptops, and guest hardware all connected to the same central switch as the servers hosting sensitive student records. Now watch what happens when a visiting parent connects a laptop to the guest network that is unknowingly infected with malware. Because the network is flat, the infection moves effortlessly from the guest laptop to the teacher PCs and directly into the grading servers. This is a lateral movement. In this unsegmented environment, the blast radius of a single compromised guest device grows to include every asset the organization owns. To prevent this, administrators use network segmentation, the process of dividing a network into smaller, isolated zones to contain potential breaches. At Oak Ridge High, architects don't need to buy separate physical hardware for every group. Instead, they use a central switch to create logical separation between users. These logical divisions are called Virtual Local Area Networks, or VLANs. The school is split into 4 distinct groups: students, staff, guests, and the internal servers. Devices within this same VLAN can communicate with each other, but the switch prevents that data from crossing over into a different VLAN. This structural change forces the network to defend itself from the inside, trapping threats within a single segment rather than allowing them to roam the entire building. If a device in one VLAN legitimately needs to talk to a device in another, that traffic must first pass through a firewall. The firewall acts as a gatekeeper, using access control lists to permit or deny traffic based on strict security rules. This architecture enforces the principle of least privilege. The firewall grants a student just enough access to reach the internet, but explicitly denies them any path to the sensitive grading servers. Combining segmentation with these targeted rules transforms the network into a controlled environment where access is granted only when it is strictly necessary. This setup works internally, but it raises a question. How does Oak Ridge High host a public website for football tickets without allowing that public traffic to reach the internal student database? This diagram shows the solution: a screened subnet, or DMZ. It's an isolated buffer zone between the internet and the internal network. The external firewall allows public access to the DMZ server, while an internal firewall blocks them from entering the internal LAN. A DMZ allows an organization to offer services to the world while keeping its most sensitive internal assets hidden behind a second layer of defense. Let's replay the malware attack on this new segmented architecture. The infected laptop connects to the guest Wi-Fi just like before, but as the malware attempts to move laterally, it hits the firewall rules. The infection is trapped entirely within the guest VLAN, leaving the staff PCs and grading servers isolated from the threat. This is defense in depth. By layering VLANs and firewalls, administrators ensure that a single failure doesn't result in a total network compromise. Containing the blast radius secures the 3 pillars of cybersecurity: the confidentiality of private records, the integrity of the data being stored, and the availability of the systems for the users who rely on them. To review, we looked at the structural tools of network security: segmentation, VLANs, and the use of screened subnets. We also covered the core principles that make them effective: stopping lateral movement, enforcing least privilege, and implementing defense in depth. Test your knowledge. Why is a flat network considered high risk? How do VLANs provide logical separation? And why would a company use a DMZ? Effective network segmentation ensures that a security breach in one corner of the organization never becomes a crisis for the whole network.